Average value of a function. The average value of a continuous function y equals f of x over closed interval a comma b is the height c of a rectangle with the interval a comma b as its base. So here we can see we have our x-axis and our y-axis. This is our function y equals f of x, and this orange rectangle is the average value. So it has a height, or you could say a width, of c. This is c on the y-axis. And it has a length, or you could say a base, of AB. So this is point A, and this is point B on the x-axis. So the distance between A and B can be written as B minus A. So the average value of a continuous function y equals f of x, so the average value of our function over a closed interval a comma b, so from A to B, so from A to B, is the height c of a rectangle, this orange rectangle, with the interval a comma b as its base, or as its length, which has an area equal to the area between the curve and the x-axis over the same interval. The value c is shown in the diagram opposite, so here's our value c on the y-axis. So from the diagram, the area of a rectangle is given as b minus a multiplied by c. So we know that the area of a rectangle is the length times the width, so a equals L times W, where the length is b minus a and the width is c. So why is this called b minus a? Well, from 0 on our x-axis across as far as b would be b, or a distance of b, and from 0 on the x-axis across to point A on the x-axis would be a distance of a. So if we subtract this from this, we are left with what's in between. So if we subtract the distance of A from the distance of B, we are left with the distance between A and B. So that's why we can label this as B minus A. So the area of a rectangle is B minus A multiplied by C, so the length times the width. And the area under the curve is the integral of f of x dx using the limits b and a, so between a and b. So thus, b minus a times c is equal to the integral of f of x dx between a and b. And solving for c, so getting the c on its own, we get c equals the integral of f of x dx between a and b divided by b minus a. So this is the average value of the function y equals f of x over the interval a comma b. Average value of a function over an interval. The average value of the function y equals f of x over the interval a comma b is the integral of f of x dx between a and b divided by b minus a. So it's basically giving us the average value of this function, but what you're really doing is getting the area of this rectangle. This formula is not in the formula book, so it would be a good idea to learn it off by heart. So if we're asked for the average value of a function, this is the formula we use. So we divide by b minus a, where b is the upper limit and a is the lower limit. Find the average value of the function f of x equals x squared minus 2x plus 3 over the interval 0, 3. So when you hear the words average value, you want to think integrate. So the average value is equal to the integral of f of x dx between the limits a and b divided by b minus a, which is equal to the integral of x squared minus 2x plus 3 dx between the limits 3, upper limit 3 and lower limit 0 divided by 3 minus 0. So the b is 3 and the a is 0, so 3 minus 0. And 3 minus 0 is 3, and technically I guess you have a 1 over here, so it's really 1 over 3, which is a third. So if you're dividing by 3, you're multiplying by a third. So then we integrate. The integral of x squared is a third x cubed, the integral of minus 2x is minus x squared, and the integral of 3 is 3x. So we have a third in front, don't forget about that. We keep the third in front with brackets, and then we sub in our upper limit, swapping each of these x values for 3. Then we have a minus. Then we sub in our lower limit, which is 0, swapping each of these x values for 0. So we get a third times 9 minus 9 plus 9 minus 0 plus 0, which gives us 3. So the average value of this function over the interval 0, 3 is 3. The volume, V centimetre cubed, of liquid in a hemispherical bowl is given by V equals a third pi times 30 h squared minus h cubed, where h centimetres is the depth of the liquid. So these h's here represent the depth of the liquid. Find the average volume of liquid in the bowl as the depth increases from 0 centimetres to 4 centimetres. So average volume, we want to think integrate. So our average value formula is the integral of f of x dx between the limits a and b divided by b minus a. So our average volume is going to be the integral of v dh, so with respect to h instead of respect to x, between the limits 4 and 0 divided by 4 minus 0. And we know that v is a third pi times 30 h squared minus h cubed. So, and 4 minus 0 is 4. So we swap this for the integral of a third pi times 30 h squared minus h cubed dh between the limits 4 and 0. So dh means with respect to h, so we're going to integrate with respect to h. Dividing by 4 is the same thing as multiplying by a quarter, so we get a quarter out here. And everything else stays the same. So next we're going to take the constant, which is a third pi, outside the integral sign. So put it over beside the quarter with brackets to indicate multiply. And then we're just going to integrate what's inside the brackets. So a quarter times a third pi is pi over 12. And the integral of 30h squared, we get 30h to the power 2 plus 1 over 2 plus 1, which is 30h cubed over 3, which is 10h cubed. And then to integrate minus h cubed, we get minus h to the power 3 plus 1 over 3 plus 1, which is minus h to the power 4 over 4, which is minus a quarter h to the power 4. And remember, we still have pi over 12 outside the bracket, so we keep that there. And next thing we sub in the upper limit, which is 4, in place of both h's. So we get this, then we have a minus. Then we sub in the lower limit in place of both h's, so we get this. And then we end up with 48 pi centimetres cubed. So the average volume of liquid in the bowl as the depth increases from 0 centimetres to 4 centimetres is 48 pi centimetres cubed. So that's the average volume of liquid. Example 2 shows that the idea of average value can be applied to many real-life situations. One of the most important is the idea of average speed over a period of time. From our previous work, we know that average speed equals total distance divided by total time. So Dad's silly triangle is helpful in this situation. So if we want the speed, we cover up the s and we're left with d over t, which is distance over time. So this is where Dad's silly triangle can help us. But what if we are given the speed v as a function of time, i.e. v equals v of t over the interval from t equals a to t equals b? Consider the so-called speed time graph shown below. So this graph here is very similar to the one that we had in the previous slide, but this time the x-axis is the time axis and the y-axis is the speed axis. And what we have here is our average speed. So time is represented by lowercase t, speed is represented by lowercase v, and our function is v equals v of t. Thus we have total time equals b minus a, so b minus a. So it's basically the length of our rectangle. The total distance travelled is represented on a speed-time graph by the area under the curve. So the area under our curve. And from the definition of the average of a function, we then have average speed equals the integral of v of t dt between the limits b and a divided by b minus a. So here again we have our formula for average speed, where the b is this point here on the time graph, on the time axis. The a is this point here on the time axis. So the distance between them is b minus a. And our limits, again, are b and a. And notice that it is with respect to t. So dt means with respect to t. Example. The speed, v meters per second, of a particle is given in terms of time t seconds by v equals 4 sine 3t. Part 1, find the total distance travelled in the time from t equals 0 to t equals pi over 3. Part 2, find the average speed of the particle over this time. So part 1, find the total distance travelled in the time from t equals 0 to t equals pi over 3. So remember, t represents time in seconds. The total distance is the area under the speed time graph. So the total distance is the integral of v dt between the limits pi over 3 and 0. So v we know is 4 sine 3t. So we want to integrate 4 sine 3t dt with respect to t between the limits 0 and pi over 3. So we use our average speed formula, which is very, very similar to our average value formula, average value of a function. And it is the integral of v of t dt between the limits a and b divided by b minus a. So we swap the v for 4 sine 3t. We swap both b's for pi over 3. So that's our b. Pi over 3 in our upper limit and pi over 3 in our denominator. And we swap the a's for 0. So our lower limit is a, and we have a in our denominator. So b minus a is pi over 3 minus 0. So next what we do is we take the 4, which is a constant, outside the integral, and we multiply it by pi over 3. So we get 4 pi over 3. And we leave the sine 3t inside the integral. So we have 4 pi over 3 times the integral of sine 3t dt between the limits 0 and pi over 3. So the integral of sine 3t is minus cos 3t. So now that we have integrated, we just substitute in our limits. And remember, the 4 pi over 3 stays outside the bracket. Now this minus that's stuck onto the cos, we can really call this minus 1. And minus 1 times 4 pi over 3 is minus 4 pi over 3. So we're taking the minus outside. So we have positive cos now inside the brackets. However, if you didn't do that, if you had left this as 4 pi over 3 and had minus cos 3 pi over 3 and then minus cos 3 times 0, you would have still got the same answer. So into the calculator, and we end up with 8 pi over 3 meters. So the total distance travelled in the time from t equals 0 to t equals pi over 3 is 8 pi over 3 meters. This is the total distance travelled. And this was got by getting the area under the speed time graph. Part 2, find the average speed of the particle over this time. So we know average speed is total distance divided by total time, so that's from Dad's silly triangle. The total distance is 8 pi over 3 that we worked out in the last slide. And the total time is b minus a, which is pi over 3 minus 0. And we end up with 8 pi over pi meters per second, which is just 8 meters per second. So the average speed of the particle is 8 meters per second.